So I figured I'd show you guys how I post a job for Millturn. One of the important things to know is where you grip the part. So you could use like the analyze distance tool here, and you could grab like this face and go zoom in maybe, grab this jaw, and there I can see in this box right here in the X category, I believe 5092 inches. So you write that number down, 0.5092. That is your, in this case it's a Doosan. This is a B-axis, the subspindle. So my B-axis grip comes onto the part negative 0.5092. Then I'm going to need an overall length of the part. So again, I'm going to grab this surface to the rear surface of the part. I've got 850 thousandths. So I write that number down, 850 thousandths. Then I pull up a calculator, and 850 plus my 20 thou of stock and a 118 parting tool, we round here to 140. So I add 140 and I get 990 thousandths. That's my total part length. And so my grip was 509 thou and 2/10. So I subtract that value. Then I need to pull this positive amount. So my B-axis move is going to go to positive 0.4808, and that'll put me in position to part the part at 20 in front of the face of the next part. And that'd be an example for if the finish I was gonna get off my parting tool would be good enough. And then if we don't get the finish we want off of parting, we can always change this value in the control of the machine and leave ourselves some face stock and maybe take a tool like our ID CCMT for the bore and come up the face and face the part. So I have my numbers that'll be useful for later. We're going to grab the operations we're going to post. And I think it might be easiest just to do this with using the backplotter to find out where they become subspindle operations. Okay, there's a subspindle op. So I grab 9 through 1. So I click, shift click, and then those are all currently rebuilt. So I'll go ahead and G1 post them. Okay, so it's telling me that I don't have a Millturn license. Which is really stupid, but I think I've had this happen before. I have to go down to the system tray and one of these icons is okay. They've got 2 code meter containers detected, and that's this program right here. And so if I go like this and I quit the code meter, then I think I'd have to actually drop out of the program. So I'll have to remember, I'm on op 9. I'll save you guys the time here. Pause it. So Millturn has this product called Code Meter that is a different type of authentication. I don't know, it's like a Weeboo Systems product or something like that. I don't know really the details on it, but it's finicky, and so sometimes it'll tell you that you're not a licensed user when you are a current maintenance customer. So I'm gonna hit G1. So I hit G1 in the main program. That brought up Code Expert, which is this place where we could have synchronized our paths, but I'm not doing that. I could also launch my simulation, but I'm gonna G1 post this code. Okay. And then I'm gonna grab this information. I'm going to copy it and bring it over to Cimco, where I have, this is my shell program, and so I could go through this shell program all the way to the turret park. So it's not uncommon for machines to have a personality, especially these multi-axis twin spindle machines. And so what you're going to find is that you're going to develop some sequence of parking the turret that works in the control and actually runs. And then after you spend a lot of time on that, you're going to use a program as a shell such as this to make it work. And that'll be one of the only ways that you can actually reliably obtain a working program. And I have a couple different ones. I have one that pulls for back turn. I have this one that just picks off a part. And so if I roll up to the top, what am I trying to do here? I pasted the code. Oh, there was a sync that I added in an earlier video that I didn't need. And it was an M900 sync. Well, actually, the easiest place to find this sync would be probably to grab Cimco and get it out of here on my other screen and look for it over here. So somewhere in this software, I believe I had, maybe it's not posting the sync because I'm not posting the program complete. But somewhere in here there was an M900 that I added. Anyhow, so I brought that code across, and I can go ahead and close this. And then what I need is my my subspindle operations, and so they are 10 and 12 because 11 was an example operation for another video. So if I push G1, up will come Code Expert again, and I can again post these two operations. And so I can grab this code and again I can drag Cimco over here. And so that's my lower path program, and I number my program sequentially, so 61 would be my lower path program. And I know that at the M900 is where my other program, where my shell begins. So here you'll see how the pickoff is handled, and somewhere in here is a grip value. Move to grip right here, this note. That's where I'm going to put my negative 0.5092 value. And then this move, I believe, is my pull. Or I'm sorry, these two values in this sequence are the two values. So 5092, we approach a position like 100 thou out. So I could call this 0.400, negative 0.400 at 50 inches a minute. And then at 15 inches a minute, we approach our final value. That's in case we have a positive stop feature on the part. Then this is my pull stock value right here. And so my pull stock value for this one is 4808. And then cut off the part is something that's going to be determined by what you're doing. In this case, my stock, I want to say, is going to be pretty small, but I probably want to build this compatible with 1.1 inch stock just for the heck of it, so that people, if they put inch stock in the machine, the tool won't crash and it'll feed to the position that I need it to feed to. So in this case, I've got a 460 through hole in my part, and I need this X value to feed to something about, I want to say something like 70 thou inside that is a reliable number to send the B-axis away with. Parts like this that have a hole in them, you got to be careful, because if the part has a hole in it, your chips can actually try to kick the part out of the spindle. And in this case, we're in a collet, so it might be okay, but we really don't want to puke a lot of chips into the subspindle. So we'll go ahead and grab a value like 380 thou for this move. And then we're going to for the sake of whatever, we're going to take the M200 right here to take the load monitoring off. We're gonna allow it to read through this line and take the spindle home, and then we're going to send the tool through the part in case there was something left behind. So I'm going to go to X negative 20 thou. And actually I should make this move in 2 moves, because anything under X 250 should be rolled at a different feed. So we'll go to I'm sorry, negative 20 here, and we'll go to X 250 there, and so feed of 0.0018, I believe, heck 2 for this one, because we might not have stock there. The idea is not to have stock there, but we want to send the part through because I want to crash my main turn tool on a nipple on the part that shouldn't be there. So this way I got it going to X negative 20. It's wrapping in front of the part here, and we're done. Well, then finally, and I'm not going to bore you guys to tears on it, but I use a product called backplot in Cimco, because I have Cimco Pro, and this product will let you, and this is weird how it came in. This is one of the things I'm not good at with Cimco is views. So I mean, most of the time the stupid software goes in relative to something. So usually you get a normal turning display, but I guess in this case I've got this stupid view, and That kind of sucks. I wish I knew how to, this is really one of those awkward softwares where the view isn't the greatest. Anyway, rotating the view isn't easy to do to accomplish anything you want to accomplish. But I can watch my code. It's like I can see this tool came in at Z4 thou in front at a height of 1 inch 90 thou, so that's fine on this program we're intending to run. And it's going to come down the face, and then it's going to come over in rough, and then make a second pass, and it's coming away. And so like I can watch all my tools in and out of the cut and make sure that every tool did what it was supposed to do. And I can see here operation 2. Oh, okay. I think maybe I missed I don't know, I'm not seeing a finish face path. Okay, so here's my finish. And what? Oh, okay. Alright, so I grew first. But anyway, I go through this nauseating kind of process of looking at all the moves to make sure that there's no stupid moves in backplot. And then I go to another step where I add load monitoring commands for my machine. So in this case, I'm making rapid moves, and I'm about to cut here. I'd add an M201, and I'd add after the move an M200, and that gets me load monitor on, make the cut, load monitor off. I wrap it in front, and I come up in X. I'm out in front in a rapid, which is just a weird move, and then I'm back, so this move is pointless. I can delete that. So see, you can get rid of unintended runtime by using the backplot tool as well. And so I go into a linear feed here, and this is the move that I'm going to want to put my load monitoring on for, and I'm going to want to take it off when the tool comes away from the part. And so that's right here. And then you watch the next cut. And the weird thing there is that, oh, okay, so I'm still in the rough, right? I was thinking in terms of my finish. But anyway, through this process of adding and removing these codes, you can get your load monitoring working, which is really critical on these types of machines you want to sustain production on. But at any rate, this is the process. It takes quite a bit of time, but this allows me to post the code, put it in a shell that works, where the program that would come off the program wouldn't post code that would actually run the machine, because the ops are high quality, but the part handling is poor. Doesn't work. The machine will spit you an error message and it'll stop the process. But then by reviewing your code, watching all your moves, you can find sometimes some motion that was wasting time, or a move that was going to crash the machine. You can make sure that all your feed moves have modals, so you can take a look at this and say, there's my G99. I know it's going to move in a per rev feed at this point, as long as I have a G01. So you can confirm you have G99 G01. You can add your load monitors for safety and process stability. I can change my tool numbers. So like T101 is actually T199 for tool life purposes. So after all these edits are done, I save the program, and this is my upper path ready to go to production. And do the same thing in my lower. That's my lower path ready to go to production. And at that point, I can successfully run a job. So that's how I post programs from Millturn.